This is version 7 of the DM3 voice display, which is the 2-board version, comprising a driver board, which is driver board version 7.1, and a display board, which is actually version 6.1. We do use the version 6 display board in preference to the version 7 display board, which wasn't really what we intended it to be. So this is the configuration for version 7 units. So let's take a quick look. This video is going to give an overview of the connections to the module and the functions of the module. So let's just start off by looking at the physical configuration of the unit. On the driver board on the back, you can see that we have a number of terminal blocks, and I've written on here the functions, which are explained in a diagram that we'll look at in a moment, because that's clearer to read it than on the board itself. So there's a set of a strip of terminal connections here. There's a small strip of 3 connections here which relate to audio inputs. There is a RCA type phono socket for audio input. There's a 9-way D connector, which is primarily for compatibility with earlier versions of the voice display. There's a 5-way connector here, which supplies the connections to the desktop indicators via a short harness. And there is a 6-way header here, which is for connection to the in-circuit serial programming facility, enabling you to update the software as and when required. If you use this connector, pin 1, which is usually it's brown on here, has to go to the left hand side. So that's pin 1 of the ICSP connector. We have onboard speaker for generating audio tones. We have an onboard microphone, which is enabled by a short link between pins S and I. And we have the microprocessor and a number of logic chips and the power supply regulators here. You see that we have a small mini USB connector, but that's only used for supplying a 5-volt power rail if you don't have the regulators connected. Normally you won't use that. So let's go ahead and look at a diagram of the connections to the unit, and then we'll power the unit up and show it in operation. Here we have a diagram showing the connections to DM3, and this is the version 7 of the hardware. That is the 2-board configuration. So let's start off by talking about the power supplies. The module can be configured so that it's all powered from a single power supply on the connection marked AC for accessory power. That power is also connected on pin 1 of the 9-way D type. Now, for compatibility with earlier modules, earlier versions of DM3, we also have alternative power supply connections on pins 2 and 3 of the D-type connector, which are also connected to the pins marked I1 and I2. Let's just say a little bit about these power supplies on the Trans Am to understand what they how they're configured. Accessory power is connected whenever the engine is running, and it's also connected when you pull the key backwards towards yourself, so that you can actually have accessory power connected without the engine running. That's useful if you want the voice modulator to work like at a car display when the engine isn't running, or just to demonstrate the unit. The input I1 is on pin 2, and that's connected to ignition power. That's the power which is connected whenever the engine is running. I2 power is an additional power supply which is hooked up to, it's actually configured so that when you crank the engine, anything on the I2 power supply line is temporarily disconnected while the engine cranks. So that's like for unessential equipment, and it's reconnected when the key drops back from the cranking position back to the engine run position. So that's quite useful, and we can use it if you want to configure this DM3 module so that when you crank the engine, the countdown isn't happening, but the countdown does start when you drop the key back from the cranking start position back into the engine run position. So that's an option, you can configure it that way, but for simplicity, the default configuration that we use for the power supplies is we configure everything to work from a single supply on pin I1. On pin AC. That's the pin 1 of the D connector or the terminal block connector marked AC. You can actually leave the other ones, the other connections I2 and I3, the other connections I1 and I2 can be left disconnected. That is the pins connected on pins 2 and 3 of the 9-way D-type. The NAP connections, which are available on the terminal blocks and also available on pins 4 through 6 of the 9-way D-type, they're just ground switched connections which enable the NAP, normal auto pursuit indicators, to be illuminated. We also have available potentiometers for varying the brightness of the display on pins 8 and 9 of the 9-way connector, and they're also available marked P1 and P2, that's potentiometer 1 and potentiometer 2 on the terminal block connections. Ground switch connections for the push buttons 1 and 2 and the latching switch SW are available only on the terminal block connections. They're not available on the D-type connectors, and they're the usual 3 inputs that we use to control the operating modes on the various dash modules. If the potentiometers are not connected at all, then the brightness of the module will operate at full brightness. If the switches, the push buttons and switches, are not connected at all, then the unit will only operate in normal running mode. We also have pins marked RX and TX on there, and those are for receive and transmit serial data from an RS-232 serial connection. The functionality for this is currently in development. In the current version of the software at the time of recording this, that's not actually functional, but the hardware is all there, and we're just developing the software to enable you to transmit via a serial link commands to change the operating modes and adjust various other functions on the module. You'll see that audio input can be taken through the 3-pin connector marked terminals S, L and M. That's speaker input, line input or microphone input. We'll speak more about those in the video which follows as to the actual connections. The speaker input is very seldom used. It's just like an alternative for an audio input that goes through the phono plug. If you want to use the onboard microphone, we need to connect the M microphone output to the L line input. Or if you want to use a audio input from a car stereo on the RCA phono plug, you would need to remove that connection. You'll see also from this diagram that we have a short wire link between the pins marked S and I on the terminal blocks. That's to connect the speaker drive output, which is on pin S, back to the onboard speaker input, which is pin I, to enable use of the onboard speaker. So, having familiarized ourselves with this strange ignition power configuration on the Trans Am and had a quick look at the connections, let's take a look at the real unit and power it up and just give an overview of the basic functions. Okay, so let's make some connections to the module. All of the main connections I'm going to put through the D-type connector, the 9-way D connector, including the power supplies on pins 1, 2 and 3, the normal auto pursuit connections on pins 4, 5 and 6, and the ground connection on pin 9. They all come through here. Pins 8 and 9, which are the potentiometers for the control of brightness, are connected on pins 8 and 9, but because I don't have those on the rig that's hooked up to this 9-way, I'm going to put those in separately from this little box right here, which also has the connections for the push buttons and the switch to change the operating mode. So Those connections we're going to make here. The ground connection from this box is going to go in on this pin marked 0 volts, so that's the third one from the right. You can see that we have a small wire link between these pins marked S and I. S is the speaker drive out and I is the internal speaker, so if we want to use this internal speaker we need a small wire link between those two pins. There's another wire link between the pins marked L, which is line input, and M, which is the microphone amplifier output on here, to enable us to use the onboard microphone for the audio input to the voice display. If, on the other hand, you prefer to use a connection from, for example, a car stereo, then you'll need to remove this link between pins L and M and put the audio connection from the car stereo in via this phono RCA plug. Other connections we have on here, we do have connections for RS-232 serial bus, but they're optional and actually not supported by the software at the moment, but they will be in the very near future. They will go in on these RX and TX pins. These push buttons that we mentioned from this small box, which are ground switch discrete inputs, they go in on pins B1 and B2, so that's push button 1 and push button 2. The latching switch, which is also a ground connected switch, on the pin SW for switch. Potentiometers, which are variable resistors to ground, go in on pins P1 and P2. Normal auto pursuit would go in on here, but as we say, we've got them hooked up on this connector. You'll also notice that there is a mini USB connector on here. Now that doesn't provide USB communications functionality, but it does allow an alternative 5 volt supply if you don't have the regulators connected. So if you don't have these regulators connected, use that, but on this unit, which has the regulators connected, don't make any connection through there. We also have connections to the dash-top indicators, which go in via this 5-way connector here. We have a common power supply, a common 12 volt connection on the rightmost pin, which is labelled plus, and then we have ground switch connections to each of the individual dash-top indicators on pins 1, 2, 3 and 4, and those are just brought out on a small harness which can be connected to the dash-top indicators. The pin that goes to the common will need to be branched off to all of the indicators on the high side, and then the individual other connections on pins 1 through 4 will go to the ground connection of the individual dash-top indicators. We also have this 6-way in-circuit serial programming port for reprogramming the module. So this is the 2-board construction that we have here. This is hardware version 7.1. The driver board is version 7.1, but we tend to use the display board version 6.1 because it's better. Other things to notice that on this version 7.1, the side of the LEDs with the writing on them, on the LED arrays, is to the right. That's actually the opposite to the new single board modules, which, just the way it was designed, has the writing to the left on the new boards. And also these LEDs here, the writing is the legend, the print of the part number, is to the right side, as it is on here, and you'll notice on the newer boards, the single boards, the writing is to the left. With these rectangular LEDs, these bigger ones, it doesn't matter which way round the LEDs go. Obviously once you put the legend on it matters, but before you've put the legend on, it doesn't matter where the writing is, they're symmetrical. So let's power up the unit, and at the moment we have the board connected so that it's using the onboard microphone input. Now when we start the module, when we first apply power, it's going to give a momentary indication of which operating mode it's going into. How's it going to do that? Because we don't have a 7-segment display on this board, so we try to synthesize the letters N for normal mode, S for show mode, O for output test mode, and I for input test mode using these. Well, you'll see if you think we've done that effectively or not. Let's start it up into normal mode. No, let's connect the actual unit up first. It does help. Okay, so now we're going to apply power to the unit. See that synthesized N? Well, it's responding to my voice as well. So once the module is powered up, you'll see that it does respond to my spoken voice. Now, you don't have to be particularly close, because the way the software is configured in this module is it's not like a volume meter. It's not looking for actual levels of volume. It's looking for variations in volume. So if I shout very loudly at the unit, or if I just talk at a normal volume, you're still going to get the same kind of response. It's going to go off scale with variations of the input. So let's see what else we have here. We can change the normal auto pursuit indications. Pursuit, auto cruise. So that's normal running mode, and you saw that temporary display of the letter N on the voice display. Let's power down. And let's try to power up in this is going to be difficult, isn't it? In show mode, by holding push button 2 grounded while I apply power. You should see a simulated letter S when we power up this time, indicating it's going into show mode. See, that's sort of like an S. That strobing effect is just due to the frame rate of the camera. So that is show mode. Let's power down again, and now let's do an output test mode, which is achieved by pushing push button number 1 while we apply power. See, that's simulated O now, so it'll run through the each LED, make sure every LED works on each of the 3 columns. It'll then simulate a kit voice display pattern and a car voice display pattern. It'll now check the side indicators, the normal auto pursuit indicators, the whole display, and now vary the brightness from minimum to maximum and back down to minimum again. Let's give it a moment there, and we'll go back down to a minimum brightness. And then the same with the light bars, checking the brightness. Varying the brightness. And then it will test the audio tone generator. And then go back round again. So if we switch off and we hold both of these buttons down while we apply power, we should get input test mode. Now in input test mode, this right hand column here is displaying the actual audio level being monitored by the onboard microphone, or if it was plugged into a phono socket from an audio output from a car stereo, then it would respond to that. These other 2 columns are indicating the analog to digital reading from the potentiometers, which control brightness. So if I vary these, you'll see we can go right down to 0 and up to maximum. That's the potentiometer that controls the voice display brightness. This is the one that controls the display brightness of the side indicators. We don't actually vary the brightness in output test mode or input test mode. because obviously what we want to do is we want to just see that we're receiving inputs. Brightness variation is only enabled in the show mode or the normal running mode. So they're the three analog displays there. They're effectively they're binary values with the least significant bit at the bottom. So you can imagine that this is the least significant bit, and the most significant bit from the analog to digital converter is at the top there. Okay, let's go back into normal running mode for a moment. You'll notice that there's a delay between applying power and the countdown sequence starting. That's deliberate, and we can change the length of that delay to anything required between 0 effectively and 25 seconds. The reason for that is because you might want a slight delay when you start the engine to allow you to crank the engine and release the key back from the start position back to the run position before the countdown sequence starts. In fact, if you use separate input for the ignition power 2, as we mentioned earlier in the video, then you can actually hold off the countdown until that ignition supply, that secondary ignition supply, is seen. So let's vary the brightness of the side indicators with this pot. You can see that we can take it right down to nothing and raise it up again. The colours are more apparent when you've got low brightness. When the brightness gets higher, the camera just washes the colour out, and you don't notice it on the camera, but you do see the red and the yellow colour with your eyes. Likewise, we can take the brightness of the voice display right down, or we can just have it very, very low, like that. So it's still responding, you see, but just at a very low brightness. That can go up to maximum brightness, and if you don't connect those potentiometers at all, we recommend probably about 47k, anywhere between 50k and 100k for the potentiometers connected there. Likewise, if we go into show mode, so show mode is push button 2 held in while we power up, and in show mode also the brightness controls will work. Likewise, if we turn the potentiometer for the voice display right down. These brightness controls are also very useful if you want to film the unit, because cameras tend to wash out the colour on these LEDs very easily, so you can play with the brightness to get the ideal brightness for filming. And that pretty much is DM3. Thank you. Now, did you notice what I forgot to talk about? I was so busy talking about the analog inputs in input test mode that I didn't mention the other inputs, the discrete inputs. So let's go back into input test mode and correct that now. So back into input test mode. As we said earlier, we've got the 3 analog displays, the potentiometers and the voice module display, the voice input display. The normal auto pursuit just respond as in normal operation with those particular inputs, but in input test mode they don't make the associated audio tone, just shows whether they're working or not. These indicators down the side indicate the power supplies. Now on this rig, the primary ignition power, that is the power that comes in on pin 2, is connected to the power on pin 1, so that's on all the time. But if you had a separate power supply on the I1 input that we mentioned earlier, that would come in, that would be indicated on that top LED on the left hand side. The secondary ignition power is hooked up to this second LED, so if I put that on, you can see that responds to that one. The switch, the latching switch, is connected up to the third indicator. Push button 1 is connected up to the fourth indicator, and push button 2 is connected to the fifth indicator. So they just give you an indication as to whether those buttons are hooked up and the microprocessor can read their states. So that does complete the video on DM3. Thank you.